So today we're going to start our work on simplifying radical expressions. What does it mean to square a number? So what does it mean to square a number? Well, you probably say, well, Ms. Fernandez, multiply times itself. I go, okay. So for example, we would say, you might say, well, so 3 squared, that's 3 times 3. And that gives us 9. Okay, cool. And 5 squared, 5 times 5. And that gives us 25. Okay? All right, so squaring a number, we just multiply times itself. So what we're going to do in this chapter is go backwards. So I would give you the answer 25, right? And I would say, what number did you square to get 25? And so in class, I would ask you, what number did we square to get 25? And some of you would say 5, right? So then we would say that 5 is a square root of 25. Okay, because 5 is the number that we squared to get 25. And so we're going to call that a square root. And I know you know this, right? Okay. But then I would ask you, is that the only number that we can square to get 25? And sometimes students say yes. And sometimes students remember that there actually is another number that we can square to get 25, which is -5. So if you remember that -5 squared, okay, parentheses is critical, as you know from using your calculator. -5 squared is -5 times -5, that also gives us 25. Then we're allowed to say that that -5 is another square root of 25. So we have 2 square roots for 25. We have 5 and we have -5. Both of those numbers can be squared to get positive 25, right? Similarly for 9, right? 9, if I ask you for the square roots of 9, you say, oh, well, there's 2 numbers we can square to get 9. We can square 3 or -3. So we're going to have a symbol rather than my having to write all this verbiage here. If I say, what is the square root of 25? This is when we use the radical symbol. If I put a square root, so here's our radical symbol, and I put the 25 inside it, and this means what number did we square to get 25? But remember that there's 2 answers. It could either be a 5 or a -5. So in order for all of us to be talking the same language, we're going to agree that if I use the symbol square root of 25, just like this, that's going to represent the positive square root of 25, which is 5. And that if I want this -5, then I'm going to have to put a negative in front of the square root of 25. That will denote the -5. So see how that works? So if we use the radical symbol, if the radical symbol is part of the expression to start and there's no sign in front of it, then we're talking about the positive square root of 25, which is 5. And if I have the minus sign in front of it, the negative symbol, then that means we need the -5. The first example says square root of 289. Okay, now I know that you know how to find the square root of 289 in your calculators, right? But if you don't, here I go. Hang on. Okay, so we're going to do second square root 289 and enter and 17, right? Okay, so number 1, answer is 17. And again, they're asking for the positive 17 because there's no sign here, right? Okay, now look at this one, square root of -121. So this is asking us for what number do we square that will give us a -121. So something interesting happens when you try that in your calculator. So second square root -121. And do you see what it says here, non-real answer? Okay, so it gives you an error message. The square root of -121 is not real. This would be in your MOER, you're going to say DNE. Why? We can't square a number and get a negative answer, right? Like if you think it might be 11, well, positive 11 times 11 is positive 121, right? And then if you think it's -11, well, when you square -11 times another -11, it's still positive 121. So how are we going to get a negative number when we're squaring, multiplying a number times itself? Well, we can't, can we? So that's why number 2, the square root of a -121, is not real. We call it not real because later on in the chapter, we are actually going to learn about this whole new set of numbers called imaginary numbers, which is going to allow us to be able to evaluate the square root of negative 121. We're going to be able to do that. But right now, square root of negative 121, not real, does not exist. Okay, go to the next one. Now see how here this is different? The negative sign is outside the square root. So this means that your answer is going to be a negative. And taking the square root of a fraction, we are allowed to split that up. Ladies and gentlemen, that makes it easier. So it's a negative. You could take the square root of 1 over the square root of 49, and that will be negative 1 over 7. Okay, so square root of negative the square root of 149, or the opposite of the square root of 140 over 49 is negative 1/7. Right? Okay, next. Cube root of negative 1,000. Okay, so here's the thing. D&E? Well, no, not this time, because the fact being that this little number here, which, by the way, the little number in the radical is called the index, okay? And that tells you what kind of root you're taking. So this time we're taking a cube root. So we want a number multiplied times itself 3 times to give us negative 1,000. And I know you know that's negative 10. So negative 10 times negative 10 times negative 10 is negative 1,000, right? Because this is positive 100 times the negative, there's negative 1,000. So this time, having the negative inside of the radical, we're okay with that. This is negative 10, right? Over here on your calculator, cube roots are in the math menu. See them there under number 4? So negative 1,000, right? So we're fine. All right. Next thing is 4th root of 16. So what number do we multiply times itself 4 times to get a 16? And I know you know from our factoring work that that's 2, because 2 times 2 times 2 times 2 is 16, right? That gives us 16. See that? So the 4th root of 16 is 2. Again, this is your index. By the way, the 16 is called the radicand, the number inside the radical. It's called the radicand. See it here? Okay. And the index. Oh, by the way, how do we do that in our calculator? Well, math menu. See this number 5? You can do any root with number 5. But you have to enter the root first, the index first. So I'm going to go back to my original screen. 5th root of 243. There it is. So 3. So that tells us that 3 to the 5th, 3 times 3 times 3 times 3 times 3, that is going to give us 243, because we have 9 times 9, which you know is 81, and 81 times 3 is 243. So the 5th root of 243 is 3. Okay, I know I'm going slow, but I'm going to speed up, I promise.